Hello and welcome back to Aerospace and Mechanical Lab 1 lectures. Today we're going to talk about the theory of hardness and talk about the hardness test, which will happen next week. Um, so let's begin. We will talk about the hardness for engineering materials. We will define hardness and what hardness is in general. And then we will move on to learning about the methods that we can use to measure the hardness of different types of materials specifically. We will move on to talking about hardness of metals, which is one part of the experiment. And then we will move on to the hardness of rubber-like materials, plastics in general, which is the second part of the experiment. And eventually we will talk about the lab itself and what you need to do for the lab, what type of equipment you're going to use for in the lab, and when the lab report is going to be due. Okay, what is hardness? Hardness is defined as the capacity of a material to resist plastic deformation or penetration or indentation and or scratching. We can use the value that we obtain from a hardness test. We can use the value of the hardness of a material to predict the tensile strength of the material. We're going to see the relationships later on. But you have to note that the hardness is not a fundamental physical property. Which essentially, there is no theory that can give us the hardness of the material. It's just an empirical thing that we have defined for each material. So we have to perform experiments to measure the hardness of material. We can't really use any theory to measure the hardness of the materials. Very important to keep in mind. We can employ two different principles to measure the hardness of material. One is scratch testing. Scratch testing is usually used for brittle materials like ceramics or glasses. The idea is these type of materials cannot withstand a huge amount of plastic deformation. They break easily, and we don't want them to break because we won't be able to use a broken ceramic to measure the hardness of the ceramic. So that's why we use a scratch testing. But for the material with a long range of plastic deformation, we usually do indentation testing, which is the testing we are going to perform in this lab. So very important, if you want to do indentation testing, the material you're using should be able to undergo plastic deformation. So essentially metals. And we are going to use indentation testing for rubber-like materials. You have to keep in mind that the indent that we create in the rubber-like material is not going to be a temporary indentation. So when you remove the hardness testing device, the indentation will go away. Okay. Indentation testing methods that are very common are, we can name a few of them. One is Vickers, which is the test we are going to use in this lab. One is Noob, Brinell, Rockwell. But the principle of all of these, and durometer, we're going to use a durometer for the soft material. The testing principle for all of these tests is essentially very similar. We are going to use a device to create a dent in a sample. You can see for the Vickers, we essentially have to create a diamond shaped dent. For Brinell, it's a ball-shaped dent, and for Rockwell, it's a cone-shaped dent. So essentially what this means is the type of experiment you have to do for the hardness calculations depend on the type of material, type of experimental setup you have, right? And the experimental setup we have has this type of tip, which means that it will create this type of dent, which will force us to use the Vickers method to do the hardness analysis, hardness calculations. And yeah, so let's move on. This is the type of device you're going to see in the lab. This is called, on the left here, this is called a micro Vickers micro hardness test. The reason we call it micro hardness test is because the loads that the maximum amount of load we can apply here is less than 1 kilograms of force. It's very important to keep in mind the units of force here that we use is 1 kilograms of force. It is not 1 newtons. And you're going to see in another video how to operate this micro Vickers hardness test. But as you can, if you notice the picture here, you're going to see a lens which will help you find the dent and measure the size of the dent. So this is the type of picture you're going to see. And we are interested in this distance. So you have to measure D1 and measure D2 and take an average or do some sort of a statistical analysis. That is the idea. And use these values in your hardness equation, which we are going to see later on, right? And this small thing, this is the denting mechanism, indenting mechanism. So you essentially have to make sure this is close enough to your sample. There is going to be a button right here. You press that button, it will create the dent, and you'll go from there. Okay. This is what you are going to see when you look into the microscope. So this is a dent you have created. When you create the dent, you have to go back to the lens right here. So you can rotate this whole thing. You can change between the lens and the indenter very easily. You create the dent by this and then rotate it to the lens. You can see this dent here. And these lines are things that you can move actually. So you move them to align with this length here, and these two lines are connected to a dial that will help you measure this distance. So that's the idea. When you measure this distance, you have to put it in this formula, in which the distance's units is in millimeters. It's very important, guys. You have to make sure that you are consistent with the units. And the force, you already know the type of force you have applied to create this dent. You have exerted to create this dent. The units for force in this equation is always kilograms of force, and the units for diameter or the distance is always in millimeters. And then this will give you a hardness value for the material that you are testing. You can use this hardness value, put in here, and if you know the strain hardening coefficient of your material, you can actually find the ultimate tensile stress of the material or the yield stress of the material. You have to keep in mind that these are not real. These are not based on real theories. These are based on experiments. So these are empirical equations. This is not a real physical relationship. This is just based on theory, which means that it is limited to the type of material you're testing, right? So this equation only works for example, copper, aluminum, and steel. Okay. For the soft materials, we are going to use a durometer. This is a picture of the durometer. Most of the durometers we have in the lab are digital durometers, so they don't have a gauge like this. It will display a number. But this is your indenter. So essentially, you press this on top of your rubber material, and it will go in. This can move, right? It will go in, and as it moves in, based on the resistance of your material to that indentation, this dial will move, or it will show you a digital value, and the value is going to be your hardest value. So unlike the previous one, you don't really need to do any calculations for the hardest value. Okay, this is how the experiment is done. Just take the indenter, you take your rubber sample. You have to keep in mind that the rubber sample must be put on a solid surface. So the dent is the only movement it sees, the only deformation it sees is from the durometer. And basically, we have different types of durometers. The durometer we use is the type D durometer. Most of them are type D durometers, but you really need to know any of this because the value you are given is the actual hardness value of the rubber material. Okay. You have to keep in mind that the minimum thickness of the rubber material has to be 6 millimeters. And the reason it has to be 6 millimeters is because we want to make sure that we see the full deformation from the indentation. If the thickness is less than 6 millimeters, that the deformation is going to be not the full deformation you will see in that material based on the indentation. You can actually stack multiple specimens on top of each other and measure the hardness value using that. But the hardness value you are going to get is not going to be exactly the same as the hardness value of a thicker material, because there are going to be layers like in between all of the layers you have stacked on top of each other, like layers of dirt or whatever, like air bubbles that are in that are going to be between these stacks material, which will affect the deformation of your rubber material. Okay, so hardness test, the first thing you want to do is you want to take a metal and one or a couple of the rubber samples we have. For the metal, you want to make sure that you polish the metal as much as possible, so you remove the dents created by the previous year's students. We do have the polishers, we do have the metals. Your TA is going to be there to help you. And then you are going to create a couple of dents, not just one. A couple of dents. You are going to measure the distance for this couple of dents. Uh, 5 times should be enough. The reason we do it more than once is because you want to, because what essentially you're doing an experiment, and experiments must be repeatable, and we have to do a statistical analysis to find the confidence interval for our hardness values. That's why you have to do it multiple times. In each class can also share the data with each other. So I would assume each group will do 5 tests, and they can share the data. So you're going to have, each section is going to have 15 data points for metals and rubbers for each of the rubbers. And then you, based on the confidence interval you have calculated for that specific material, you have to go up to like internet and find a source for hardness values for different materials and find the material you are testing. So a statistical measurement is one job, one of your jobs, and then after the measurements, you have to do the analysis, do the statistical analysis, find the confidence interval, take the values to internet, and identify the material. And I mean, the error measurements is a part of the statistical analysis. That's it for the theory of the hardness test. Please let me know if you have a question. I will be in class next Monday. That is Monday. I don't know. Let me bring up the calendar for a second. That's going to be Monday, February the 3rd. I will be in class, and to answer any of your questions that you might have about the hardness of the material.